So this one, for example, 12 here, you don't have to start with A, but oftentimes it allows you to do that, right? So what we know is that if these two lines are parallel here, I'm going to use a highlighter, right? If these two lines are parallel, then this technically is a transversal, right? This line here, which I can extend, is a transversal connecting the two parallel lines. So we know that these two are supplementary, okay? They're called consecutive interior. If these are your parallel lines, these are technically interior, right? So that's where you get the 115 from, right? So this should be 115, and you get that there. So the explanation, which I would strongly encourage you to do, consecutive interior. I'll do the attendance in a bit, okay? I just started. This is the chapter test that I assigned yesterday for you to do, right? And once you have A taken care of, right, you can actually, maybe it'd be a good practice to just write it in. That way you have fewer unknowns there. What can you do next, right? B is not, if you think about it, if you now focus on this other transversal, I only have two different highlighters here. If you focus on this transversal here, connecting the two parallel lines, right, the 30, right, these are my two parallel lines, is the transversal that connects it, and your Z is formed right here. So B and 30 are alternate interior. So you can say that B is 30. They're alternate interior. Okay. And now that you have three angles, there are three along this straight line here. So you know 2 out of the 3, so C can easily be found, right, by just going 180 minus 115, right, this one here, minus 30, and that gives you 35 degrees. Okay, so this is 35, and it's just a straight angle right here with 3 sub-angles, so to speak. And then now you need to find D. There's a number of ways you can do it. You can use the alternate interior, right? Because this is technically a parallelogram, so you can jump, right? You can jump from this line to this line, or from this line to that line. But D would be alternate interior to C. You can just say it's 35. Alternate interior to angle C, right? You could have also said that this over here corresponds to this over here. So you know that this whole thing has to be 65. So you go 65 minus 30 to get you the 35 in there, right? And that's where you get the 35. So corresponding, alternate interior, you name it, could have been used. So the closer you get to filling out the rest, the more options you will have. Okay. And by all means, if ever you see right, a triangle, right, you can actually, right, this one right here, these two are along a straight line, so you could have actually said that this is 115, and we know that, right, 115 and 65 is supposed to add up to 180, so you could have found it that way. 180 minus 115 minus 30, you still get the 35 there. Okay, so that's that. This one, actually, if you go back to your notes, we did this one in our notes, something similar to this. Okay, so the first thing to start you off here, I'm going to highlight the parallel lines. Maybe that's something that's very important to do. Right, this parallel line and this parallel line. And we see that this is the transversal connecting the two. right? So maybe having a highlighter is very useful. So we know that, right, if you want to make a Z, if you're not sure, is that go with the F, make a Z. Go like this along the parallel line, come down the transversal, and then go the opposite direction. And there you can see that these are alternate interior. Forget about this one, right? You just follow that transversal and you get the 25 here. So F is the one I start with, which is 25. Now you have a bunch of triangles, right? This is a triangle. You have 2 out of the 3. You can easily find E there, and that's 110, right? Just doing some mental math. C, therefore, is vertically opposite 110. So it's almost like if you find the one that connects, the one, I'm usually going to have one hidden somewhere across so that when you bring it over, the puzzle just comes together. Okay, so it all started with a 25, the alternate interior property, and now we're using sum of triangles is 180 and vertically opposite and straight lines, right? Because E, they don't want this one. They want D though. There's a straight line here. So D would be 70. Right, this would be 70. Now you have another triangle here. You can easily find B using this triangle. So 70 plus 50, that's 125. So that would be 55. Okay. And then A, how would you find A? Let's do the Z thing. Can this one go with A maybe? Start going this way, use the transversal to get you across, and then keep going that way. It's like that Z there. Those are alternate interiors, so A is 45. And there you have all the angles. Just by, it all started with the fact that these two are parallel, and then you go with it. Okay. This one should all be done using the calculator, right? The interior angle, the sum of the interior angles, right? That's that S formula, the I, the E, and always remember that E, so I plus E or EI is equal to 180, always. So you can use, like if you have the interior, you can easily find the exterior by just subtracting it from 180, okay? Because they're always supplementary along the vertex there. Determine the measures of angle PQRST. Again, okay, highlight the parallel lines. Make them stick out, right? I would start with, there are a number, you can start along this transversal or this transversal. But if you focus on this one right here, we know that 65 and T are corresponding. Okay, so T is my first go-to, and I'm going to say it's 65. Corresponding angles are congruent. Right? That's my first step. You know that S is supplementary to 65 because they're along a straight line, right? So it's 115, right? S is going to be 115 because they're supplementary. And I'll just say straight angle. So you got S taken care of. Let's go over to this side. We know that these are consecutive interior. That's one way of doing that. So R is going to be 180 minus 30, that's 150. Consecutive interior angles. Right? So you found this. These two are along a straight angle. Or you can say that 30 is corresponding to Q. Okay? So you could say that Q is equal to 30 degrees. It corresponds, corresponding angles. And then P, last but not least, you've got this small triangle here, right? Or you have the large triangle out here. Either one will work. So angle P, I'm going to go 180 minus 65. So these two are 95, so that P is 85. Sum of triangles equal to 180. They only ask you, well, they ask you to give reasons actually, so that's what I mean. If you want to do the, I'm just going over this, right? I'm not giving you like the extensive way of doing this. You want to show your calculations as well here. So I will normally on a quiz or test, I will usually have a chart like this, right? And I will you will have like something like this, and I will tell you, hey, find what T is, right? And then you put down the angle measure. So let's say it's 65 degrees, and here you have to put the explanation or the reasoning, and you can also do your calculations there. So that's how I'm going to have it set up every time you have to do something like this, where a reasoning needs to be provided. Okay, and so it's going to be like a 1 mark per answer, but you get half for the number and half for the explanation. Okay. All of these were just using your formula, so those you should be able to do. Determine the sum, that's just using your formula. Kim measured one interior angle of an irregular convex pentagon. She claims that the sum of measures of exterior angles would be 5 times 65 or 325 degrees. Is she correct? Explain. No, I'm just going to skip that. I don't like to explain, right? On a test, that's what we always do, right? I'm going to get to it later. But don't leave it blank, okay? It's irregular. What does irregular mean? It means that every single angle inside is going to be different and every single side length is going to be different. Okay? You're not guaranteed that every vertex is going to have the same interior angle. Therefore, as the diagram already suggests, you can't assume that if this is 65, you can't assume that this will be 65 and that this will be 65 and that this will be 65. You can't assume that. They're all going to be different. So you can't just say, hey, right, 1, 2, 3, 4, 5. It's a pentagon, so if this is 65, it's just 5 times 65, done. We know that, right? It always adds up to 360 anyways. The exterior angles, the sum of the exterior angles is always 360 degrees. So if it's an irregular, you would have to know, every single one would have to be given to you for you to be able to correctly answer that one. So it's not correct. Four, I don't know if you caught that one, a 14-sided convex polygon. They're not telling you, we're always going to have convex, by the way. We're not going to have one of those concave ones. You don't have to worry about that, but they're not telling you it's regular. They're asking you, is it regular? A regular polygon, right? Oops. Would have to have this interior angle. So you go I of 14 is equal to 14 minus 2 times 180 divided by 14. Okay? So you're supposed to get 154.29 degrees. If you have a 14-sided polygon that has this interior angle, every single angle, then it is regular. since the one you're given has a 155, right? Has one that's 155, it is not regular. Since 155 does not equal 154.29, right? It is not regular. That'll be your answer there. And then there were some tessellations, right? Where you basically, how do you know something tessellates, right? Can you divide the interior angle into 360 evenly? Right, so 60 goes into 360 6 times, so yes, it will tessellate. Square is 90, does 90 go into 360 evenly? Yes, it's 4, so yes, it will tessellate. Pentagon is 108. 108 does not go in there evenly. Hexagon is 120. 120 goes in there 3 times, so yes, it will tessellate, and so forth. So that's how we check for tessellations. Okay, so any other questions about this one? Number 7, you won't be able to do, well, I will never say never, but 7 you wouldn't be able to do yet. I will do that one today, okay, something like this today. So if you couldn't do 7, that's okay for that to happen. And then at the back, with my awesome handwriting, right? I added that later on after I already printed it, so I wanted to have this. So James is a contractor and has been hired to lay down tiles. He's considering the following shapes. All shapes have congruent sides, so they're regular. Okay, triangles and squares. Is it possible? If so, what combination would work? Show all calculations. Include diagrams if possible. So what you have to do here is find the interior angle of a triangle. And we know that it is 3 minus 2 times 180 over 3, which is 60, right? Okay. The interior angle of a square, I think we're just going to say 90, right? So does that work? We go 360 minus 60 minus 90. That's the first, you take away all the ones that you have, right? And so that would be 210. So this was a triangle and a square. And you keep going. 60, 90, one of each. And that gets you to 60 degrees. So this is a triangle and this is a square. So so far you've used 2 triangles and 2 squares, but you still have 60 degrees left. So we're gonna use another triangle until you have nothing left. So using 3 triangles and 2 squares will tessellate. And there it is. Okay. We're going to continue with our notes. And if you haven't done this worksheet completely, I strongly urge you to do that, because that is the kind of stuff that I'm going to expect you to know. Okay, so go look at your notes, see if you need to look back. And so we're going to continue. So today we're going to do the inscribed shapes, okay? And that's in section 2.4 of our textbook. And you know what? I'm going to